Hello, beautiful chemistry people. Let's take a look at our conversion review from last semester. What does this say? So far, we have learned several different ways to convert between units in chemistry. Alright, so we're converting between units, and obviously it's chemistry. Two of the most important conversion factors, that sounds important. So, factor for converting. We've used have been molar mass and Avogadro's number. Okay, remember molar mass is from the periodic table. And then Avogadro's number is the 6.02 times 10 to the 23rd. As the conversion diagram below shows, we'll have to look at that in a second, molar mass is used to convert between moles and mass. So I just put molar mass is for moles to mass. And then it says Avogadro's number is used to convert between moles and amount, where we use the term amount to mean particles, atoms, etc. So I can put Avogadro's number is for moles to amount. Moles to amount. Alright, whoa, that did not come out well, but I guess you can still kind of see it. Let's look at this factor, or the conversion diagram, right? Something I noticed is moles is in the middle here. Right, so if you want to go somewhere, you have to go through moles. And then, like it said, mass and moles, you use molar mass. And remember, this is from the periodic table. Mass is grams. Moles to amount, you use this 1 mole equals 6.02 times 10 to the 23rd, and that's Avogadro's number. And then these other two weren't mentioned in the reading, but it looks like moles A to volume A is 1 mole equals 22.4 liters. That's at SDP. Has to be a gas. And then moles A to moles B, we use the chemical formula. This is or equation. Since we've been dealing with equations a lot recently, I have a feeling we're going to use the equation in the coming lessons since we've used the formula before. Let's see, what else? Here are some additional reminders on how to solve conversion problems. Box what you're trying to find, circle what is given to you. Well, basically, this is saying annotate. I think I actually changed this. I think we've been doing it the other way, but whatever. The point is, you wanna know what's given to you and what you're trying to find. Plan out the steps you're gonna do. This is like where they do the mole A to mass A, that kind of thing. So do that. In a conversion factor, the top and bottom must be equal to each other. You can only multiply by 1. Okay, so like for water, we use the molar mass. So it'd be like 18 grams of H2O is equal to 1 mole, so I could use this as a conversion factor. Or flip it over, they're still equal to each other. And then use the correct conversion factor. That is not really a very helpful reminder, is it? Because if you don't know what the correct conversion factor is, you're not, I mean, obviously you would want to use the correct one. So I think I would just say use diagram. So like for instance, if you're going between mass and moles, it tells you right there on the line to use molar mass. And you will not be given this on the test. I know you were before, but we're trying to, get better. But after you do all the practice and homework and everything, you shouldn't need it, because you're really you're memorizing 4 different things. But between this and this, what do I use? This and this, what do I use? So remembering 4 things is not hard, and then you've just got to be able to put them together. That's all, Alright, let's see, what is this? I should change color. Alright, so let's look at these examples. If an 11.2 liter balloon of hydrogen gas at STP explodes, how many particles of hydrogen burn? Alright, so they give us 11.2 liters. We're looking for particles. And then it looks like they planned it out right here, volume, moles, amount. So if I look here, I'm going volume, moles, amount. So I'm going to use 20.4, and then I'm going to use Avogadro's number. Let's see if that's what they did. They go liters, 11.2 liters, H2, times 1 mole over 22.4 liters. So they're using the 20.4 liters like I said they would, equals half a mole. And then they use Avogadro's number. Notice this molecules equals 1 mole because that's the equality. And the top and bottom have to be equal. Okay, let's look at this next one. How much would 1.2 times 10^24 ionic particles of aluminum oxide weigh? So they're giving us this many particles. They're asking for weight, which is mass. Not technically, but whatever. Okay, so we're going from particles to weight, so that would be amount to moles to mass. Okay, so they use Avogadro's number first. I notice that it's flipped compared to this one, because here moles had to cancel out, so they put moles on the bottom, whereas here the particles have to cancel out, so they put moles on the top. They get moles, then here they use the molar mass, and oh, they didn't use it here, but notice grams is on top, and they got this from the periodic table. Okay. Interesting. So I wonder how they go moles A to moles B with the equation, because I'm still not seeing that. But I guess it's a review, so it's understandable. Alright, give a try on these 4 questions. You can pause the video now, and in about 10 seconds I'm going to start going over the answers to these. So you want to try them on your own first before you listen to me, okay? You should have paused it. Okay, I hope you paused it, and now I'm going to start going over them. Some of them I'll type out, some of them I won't. So what must be true about a conversion factor in order for it to work? Well, if we go back here, I'll do this one in purple. The top and bottom must be equal to each other. So that's what I was saying. So you can't just pull random numbers, they've got to be equal to each other. Which conversion factors would you use to convert between the following units? Write the actual fractions. So mass of water to moles of water. Mass to moles, we'll use molar mass. Whoops. So we use the periodic table for that. Water is H2O. So mass of water to moles of water, we would want moles of H2O on top, grams of H2O on bottom, and then oxygen is 16. Each hydrogen is 1, but there are 2 of them, so we multiply that and we get 18 grams per mole. So 1 over 18 grams. So that's for this one. Moles of water to molecules of water. So we want molecules. Oh, I should use my diagram first. So moles to amount would be molecules, so we're going to use Avogadro's number right here. So we put molecules on top, because that's what we're going to. We put moles on the bottom, and then we know 1 mole is 6.02 times 10 to the 23rd molecules. And then molecules of water to mass of water, I'll look up here, be molecules to mass, but I cannot go straight there, that doesn't work. I'll get rid of that. So we have to go to moles and then mass. So this is actually 2 steps. So here, I'll do this one, another one. So molecules to mass, first you would want to go to moles, so you'd go 1 mole of H2O, is what you're going to, and then you gotta divide by molecules of H2O, so it'd be 6.02 times 10 to the 23rd. And then your second conversion factor, you would then want to get rid of the moles, so you'd put moles H2O on bottom, and you'd want grams H2O, and you have to use the molar mass. So it'd be 18 grams over 1 mole. So those would be your 2 conversion factors. Calculate the molar mass. Well, I kind of already did this one. It's kind of hard to answer question 2 without doing that one. And then calcium carbonate. Calcium is 40 grams per mole. Carbon's 12. Each oxygen, there's 3 of them, is 16. Okay, so we get 48 plus 12 is 60, plus 40 is 100. Mental math, what? And then what is a mole? That one I can just type. Whoa, everything disappeared. What is a mole? A mole is a group of particles totaling 6.02 times 10 to the 23rd. There you go. Alright, pause and replay as needed. I hope this was a good review for you. You're all beautiful creatures. Bye-bye.